In this video, we're going to take a look at a z-score statistics scenario. We have the results of a 5K follow the normal distribution. The mean finishing time was 23.9 and the standard deviation was 5.1 minutes. Determine the z-score for a person with a time of 17.3 minutes. So looking at z-score, what we're doing with z-score is this z-score will give us an idea of where we're at in comparison to the rest. Z-score is really useful for comparing two different sets of populations. Like if you wanted to compare the men's winner of the 5K compared to the women's winner of the 5K and how they did compared to their peers, like who won by like who was better than everyone else by more of a margin, the z-score could tell us that information. So the z-score tells us the number of standard deviations we are away from the mean. So if I have a standard deviation here above the mean, standard deviation below the mean, 2 standard deviations below, 2 standard deviations above, the z-score tells us where we're located on this curve. So if I get a z-score of, let's say, 1.5, that tells me that I am 1.5 standard deviations above the mean. So I am right here above the mean. Then if I was to compare something else, like another set of data, and they had a lower standard deviation, or I'm sorry, lower z-score, then we'd say that this person or this object or whatever we're comparing has a higher z-score, therefore it's further away from the mean. So in this scenario, we have the person running a 5K, and we want to compute their z-score. So z-score, the formula for z-score, is the x value that you're trying to calculate the z-score for, minus your mean, and it could be population mean or sample mean, we'll call this example population, divided by your standard deviation. So mean and standard deviation. And again, it could be x minus your sample mean divided by your sample standard deviation, but in this case we have population data, so we're going to use that. So my z-score will be x, which I'm computing the z-score for this, so this is going to be my x, that's 17.3, minus the mean. Mean was provided as 23.9, and then the standard deviation, while we're just writing down some information, standard deviation is 5.1, so I'm going to have 17.3 minus 23.9 divided by 5.1. So let's go ahead and compute this. 17.3 minus 23.9 divided by 5.1. And that is negative 1.29. One note I do want to make, and this may be something where you're like, yeah, I don't need to know about this because I'm pretty good with my calculator. If you're new to your calculator, like a TI, I have a TI-30 here. If you have a TI-30 and you're trying to type this in, you want to make sure, if you're trying to type it on one screen, you want to make sure you put that in parentheses. Because if you don't, your calculator is going to do 17.3 minus 23.9, and then it's going to divide. It's going to do this, 17.3 minus 23.9. It's going to do this. It's going to divide the 23.9 by that 5.1. Not 5.1, 5.1. Because the calculator doesn't know that you want it to do this and then divide by 5.1. It's just going to do order of operations. So you not putting those parentheses in is going to tell the calculator, do this, and then do 17.3 minus whatever that it comes out to be. So if you're trying these out, if you're doing homework or something, and you're not getting quite that answer, the answer is looking weird, it's probably because of that. I would just do 17.3 minus 23.9, hit enter, then divide the answer by 5.1. But anywho, we get negative 1.29 as our z-score. So that tells us that we are 1.29 standard deviations below the mean, because we have a negative z-score, so we're below the mean, so we're right about there. So as we're talking about this, if I were to compare, let's say, like -2, like somebody had a z-score of -2, like we're comparing the men's results to the women's result, -2 would tell me 2 standard deviations below the mean, which would put me down here. So the case where we have a z-score of -2, just for example, they would do better because they would be further above the mean. And we're talking about running a race, so you want to be faster than everybody else. So the lower z-score is better because you're quicker than the mean running time, because this mean running time is right in the middle, and the mean is 23.9, so that means that 23.9 minutes is the average, and then we start to calculate the standard deviation from there, getting that bell curve and everything. but a negative 1.29 would tell us that we were 1.29 standard deviations below the mean. And then just making up an example here, if we were to compare to somebody else and they had a z-score of -2, they'd be 2 standard deviations below the mean, which means that they are faster. So z-score, normal distribution, if you're taking a stats class, comes up again and again and again and again and again. It's really, really important, and it lasts throughout all of your statistics class. Like it's not something that's just talk about this for a minute and then move on. Like it's really, really important. So hopefully this gives you a little bit more understanding of z-score.